Okay, so we are also live on our LinkedIn and YouTube channel. So people who are watching us live, please you can share the live link with your friends or colleagues who wants to join the webinar at the end, at the last minute. And for the people who are joining us on Zoom, you can share the live link of this webinar from Recruit's channel, because we're also live on our LinkedIn and YouTube channel of Recruit. So we'll just take 1 to 2 minutes, guys. Will not take a lot of your time. So once we have people joining in, I think we can get started and we'll be good to go. For the people who are joining us on Zoom, please drop your questions in the Q&A tab and not in the chat section, because chat section is for the informal conversations and Q&A is for the questions that you are actually having based on the topic that we're discussing today. And for the people who are joining us on LinkedIn and YouTube, make sure that your questions are dropped in the comment section, because I'll go through the questions and I'll make sure that they are answered from the speaker. So yeah. Okay, Sumit, I think we can get started. We'll not let people wait more for the people who are actually joining us on time. Yeah, I think we are good to go. So hello and welcome, everyone. Hope you're keeping well and staying safe. This is Hafsa Anjum, and I'm working as a community executive at Recruit, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network, and grow professionally. So those who don't know about what Recruit is, we are a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as Curefit, Udan, Swiggy, Dunzo, etc. So welcome to Recruit Talks again. And today we are doing a webinar on high-level system design of an e-commerce platform. Our guest speaker for today is Sumit Jain. He's a VP technology at Mr. Milkman. He has over 9 years of experience in the software industry with a diverse range of skills across the multiple domains. Throughout his career, he has gained experience in various areas such as backend development, front-end, infrastructure and security, and DevOps. He worked with a wide range of technology tools and programming languages, and he's also an entrepreneur who actually had a startup and is a developer come entrepreneur. So we are very glad to have you here, Sumit. You can go ahead and say hi to the audience.
Thank you, Hafsa, and hi for everyone. And I'm very excited over here for delivering this webinar around e-commerce system. And thank you, Recruit, for this opportunity. Right. So I'll get this started.
Yes, I think before we start, I have a few announcements to make. You can post your questions in the question section, Q&A tab on your screen for the people who are joining us on Zoom, and for the people who are watching us live on LinkedIn and YouTube channel, do not hesitate to post your questions in the comment section, because we'll be taking up the questions in between of the presentation. So don't hold yourself back from asking any questions. We'll be rolling out the polls in between, so please do answer them and keep your notepad handy. Whatever you're learning from this webinar today, we'll be more than happy to see your learnings. And on your LinkedIn and Twitter, and please tag Recruit, please tag Sumit on it, and tag me, and then we'll be good to go. Sumit, I think we can get started with our presentation. Yep. Let me know if you're presenting.
So started the presentation, the screen sharing. Can everyone see it?
Yes. Yeah.
Great. So as everyone knows, today's topic is the high-level system design of an e-commerce platform. So what you're going to go through it in the whole next 1 hour, and what you're going to get from it is a very high-level blueprint of an e-commerce platform. Or in general, you can also apply those techniques to develop any other kind of platform. So it's going to be a blueprint around multiple aspects, functional aspects of a system, non-functional aspects of a system, and the interfaces that an e-commerce system needs at a high level, right? So as Hafsa has already introduced myself, so I'll skip this slide now. So what is e-commerce? I'm sure most of the people know, but then just to cover the basics, I'll quickly read out on this slide where you already know that e-commerce platform is a software application that enables businesses to sell products or services online. Very similar examples like Flipkart, Amazon, etc. Right? What it do? It typically provides a suite of tools and features to help businesses make their store online, manage their inventory, process payments, and then eventually deliver the product or service to the consumer, right? And it also provides consumers with the user-friendly interfaces, for example, mobile applications, desktop applications, websites, etc., so that customers can place orders and can pay online and eventually get the product. So we all are familiar with an e-commerce platform. So let's get ahead and we see what are the forms of e-commerce, or when you're building an e-commerce platform, what are the different forms that you can eventually host or you can build through. So typically there are two. One is that you can yourself build it. So let's say you're working for a company or a company decides to launch an e-commerce platform. What they can do is they can themselves build it and host the whole platform by themselves on any cloud, for example, AWS, GCP, Azure, or maybe on-prem infra. So they buy their own servers, install it in their certain data centers or office, and then host it. Or second option is they go for self-hosted solutions, no-code solutions, which requires less effort as compared to building it completely. So some examples of self-hosted solutions include Shopify, WooCommerce, Magento, BigCommerce. I'm sure Shopify is a very well-known name among everyone. And again, example of some companies which operate on these platforms: Flipkart, Amazon, ShopClues, Myntra, Meesho, etc. Right? Now, for any e-commerce platform, there are typically three types of components or requirements. One is functional requirements, and the second one is non-functional requirements, and third is interfaces. So I've covered the major modules and the major things over here. So for example, in functional requirements, what do you need typically? First of all, is an auth system or a user management system, which stores and processes all kind of users in your system. For example, there's a customer, there are delivery riders, and there are administration staff at the end of the e-commerce company, right? Then you need cataloging and inventory system where a company can upload their catalog. For example, all the products that they're selling. They're selling mobiles, they're selling, let's say, a fridge, refrigerator, etc., etc. So the whole catalog typically categorizes in multiple categories, multiple layers, and the whole catalog can get digital or online, right? And then you have inventory around it. So at a typical point in time, you might have, let's say, 100 phones available in your inventory, and then it can get out of stock. So all that comes into the inventory management system. Then you have order management system, where a customer is able to place an order. It is linked definitely with catalog and inventory. And once the customer places an order, which eventually takes cart into place. For example, when you go on Flipkart, you add products to your cart, or you can eventually directly buy as well. But then cart is also part of the order management system. And then you pay, right? And for payment, you have multiple methods or multiple instruments available. For example, credit card, debit card, UPI, etc. Right? And every payment system behind the scene works with certain payment gateways. For example, Razorpay or BillDesk, etc., etc. So a full-fledged payment system is also a very important part of your e-commerce system. And payment system also takes care of CODs, cash on deliveries, right? Then once the order is placed, payment is done, and a successful order has been created in the system, you need fulfillment. Now, what is meant by fulfillment? Fulfillment means giving the product or service to the end consumer. So over here, fulfillment means delivery of your products. So fulfillment again comprises of its own life cycle, where once an order is created, the order goes to certain warehouse where those products are stored. And then itself, there's a life cycle. For example, products are packed, products are then shipped from the warehouse, then they go to certain hubs in the way. For example, if a product is coming from Bangalore to Gurgaon, there are multiple hubs where they stops. And then finally, eventually reaches to the customer. Now, customer may accept it, or it might happen the customer rejects it, for example. So then refund happens. So all that is part of the fulfillment system. And again, fulfillment system is typically linked to payment system, because In case of refunds, you eventually has to refund the customer to its original payment method, right? Then comes in analytics and reporting. And this is a very critical piece for any e-commerce platform, because unless you have good analytics and reports, as a business or as a company, you cannot decide what to do next. What inventory is being purchased, what SKUs are being purchased, what type of customers do I have, where do I have, right? All those analytics and reporting is a very critical component of an e-commerce platform. Then you have communication system. So which is very obvious, where once you place an order, you receive notification or SMS or email that, hey, your order is placed. This is the order item details, and this is the whole order amount, taxation, invoice, etc. Similarly, when the rider is on the way to deliver a product, etc., time to time you get certain communications on different channels. It could be WhatsApp, SMS, email, or push notification on the app, right? Then you have invoicing system, because every order that you place is associated with an invoice that you would need. And typically invoice is a PDF, is a could be a bulk invoices requirements at the company's end, where they need to download a list of invoices, let's say in an Excel sheet or in a CSV sheet for their own purposes. So that all comes under the scope of invoicing system. Then you need ticketing systems, because as a consumer, you might have certain complaints, or you might have certain problems, and you want to report it back to the client, right? You report it back to the platform or the company. So for that also, you need a ticketing system or a help and support system, which eventually has certain two parts. One is typically FAQs, where you can see all these FAQs into the application, and you can report certain issue or a complaint to the company, right, to the platform. And then you have custom reports. This is again an important part, because within the organization or someone who's working in a e-commerce platform, time to time you get requests for generating custom reports. Now these custom reports can be fetched directly from the database, or you might have to write your own custom code as a developer to generate these reports as required by business folks in your company, or product managers or operations team in your company, right? So these are the set of functional requirements that any e-commerce system should have, or any e-commerce platform should have, right? Then comes in the non-functional requirements. Now, even if you build all these things, there are certain key factors that you need to take care, so that your platform is always available. It works at the fastest speed as from a consumer perspective. So for example, if you are opening in the app and you want to check out certain products, it should be loaded quickly, right? So that's what latency is. Then it should be secured, so that your customers' data and everything should not be compromised. And then you should have observability on top of your platform, so that whatever is happening within the platform, for example, if certain APIs are slow, if certain services or modules are not working properly, that observability is something that you need on top of a platform. So the functional part typically covers the software development, and the non-functional part covers the other aspects of a technology platform, where it is related to infra, how you're hosting it. It is related to security, and it is related to monitoring and alerting. So apart from just software development, any technology platform has these three other pillars as well: infra and hosting of your platform, security, and monitoring and alerting, right? These are the four major pillars of any technology platform. And these four pillar technique you can apply to build any other platform apart from e-commerce, right? Unless you have these four figured out, you might not have a very good e-commerce, very good platform or technology platform, right? And then you need certain interfaces for any platform, right? Whether it is e-commerce or any other industry, whether it's a food industry or Uber kind of industry, you need certain interfaces or mobile applications or websites on which certain consumers and users can interact with this platform, right? So you need customer application, you need delivery rider application, where delivery rider can see, okay, which product to pick from warehouse, where to deliver, etc. And then you have admin portals for different stakeholders. So for example, the owner of the company would like to see all the data. The warehouse manager would like to see certain data, etc., etc. So you need to have different admin portals for different stakeholders. I hope this is all clear. If you guys have any question, please write it down. And around these components, we'll discuss at the end. So over here, I'll quickly show you typically a workflow of a very high level workflow of how an e-commerce platform works or looks like. So a customer typically raises an order to the platform that, hey, I need to buy this product. I made the payment. This request or this information then floats to warehouses, right? And then from warehouses, the delivery trucks or delivery boys picks the orders and items, and then eventually delivers to the customer. Now, what are the different approaches to design such a system? So typically there are two approaches. One is a monolithic architecture, and second is a mini monolith. I call it mini monolith, or a true microservices architecture, right? It's not necessary that you always need microservices. And it's again, not necessary that you just stick to monolithic. It totally depends on various factors. For example, how much traffic your platform today has, what is the size of your platform, what are the number of requirements, number of features that your platform has, that your apps has, etc., right? So if you are building a platform from scratch, if you're building a company from scratch, if you're writing or you're building this platform from scratch, it is most of the time it is fruitful to have monolith architecture. And as you grow, as your company grows or as a platform grow, then only start plugging out certain modules from that monolith and start creating mini monolith or mini services. And then at a very later stage, you eventually convert your whole platform to true microservice architecture, right? Lot of software developers make a mistake that at the start, they get fascinated by microservices architecture and they start creating everything in that fashion. But then although true microservice has its own pros, but it also has disadvantages. So because it is very hard to maintain, you have a lot of moving parts, you have a lot of duplicated data. You need a bigger team to run or to maintain a microservice architecture, right? So it's always to take step-by-step approach, starting from monolith to mini monoliths, and then to again true microservice architecture. And again, you can find a lot of videos on internet where people have really talked about that you do not always need microservice architecture, and you really need to think about and not go towards the flow or hype words that, hey, we should always adopt microservice architecture. Now let's talk about monolithic architecture, how you can build an e-commerce platform in this fashion. So this is a very high level workflow where I've shown a very big circle of e-commerce system, because again, as I said, it's a combination of all the modules in one single repo or one single project or one single platform. So all the functional modules that I got you through, these 10 modules are all in one single repo, in one single project, right? You can choose any tech stack. There are different tech stacks available, but we'll not talk about that in this webinar. That's a bit more into detail, the low-level system designs of it. So you can choose different tech stack, for example, Python, Node, or Java, or Go to build this whole repo or this platform. But then with monolith, you cannot choose two different tech stack to build two different modules, right? You have to choose one tech stack to build all the modules. That's how monolith works. And then you can have one database. Again, it could be a SQL or a NoSQL database, or just in-memory databases, depending again what kind of platform you're building. But generally, typically with e-commerce, you choose MySQL if you're going through a monolith approach. And again, that's the disadvantage of monolith approach. You cannot choose different databases. In fact, you can choose, but then it would be hard to maintain in a single monolith approach where your repo would be connecting to two different databases. So it's always at the starting, it's always a good approach to take one single database and very simple design, a very minimalistic design to start your e-commerce platform if you're building in-house. And then in that minimalistic design, you can have a replica database or a master-slave architecture to make sure that all your analytic tool is not hitting directly your master database. It is hitting directly your replica database, so that if you run any query, which is time-taking, which is not efficient, it does not take your master down. And then you can use certain analytics tool, open source analytics tool, for example, Metabase, which you can host yourself, or you can use it, their cloud-based online platform, to connect your database directly, and it shows you very good graphs. You can build graphs using UI and using SQL queries. And then you have load balancer on top of your whole system, which can eventually serve all the traffic from your customer application, from your admin portal, and from your delivery application. So this is a very minimalistic design of an e-commerce platform in a monolithic approach. Now, the question comes, even if, let's say, we choose a monolithic architecture, how do we horizontally scale it? Right. So what you can do, you can run multiple instances of the same repo on maybe on same server on AWS or on any cloud, or on different servers, but multiple instances. And with the load balancer, with the help of load balancer, it will divide the traffic into one of those instances, depending on the availability of that instance. So you can have multiple rules on your load balancer. Typically, by default, it's round robin. So it divides the traffic. So this way, you can horizontally scale even your monolith architecture. So generally, people say, I've seen people talking about that, hey, you cannot horizontally scale in a monolithic fashion. You need to first move to microservice architecture, and then you can horizontally scale. That's not true. You can eventually scale. Yes, the cost would be higher, but then if it's the need of the hour, it can be done, right? And then the traffic from all your client applications will be automatically bifurcated and divided between these three instances. And all these instances will be connected to the same database. Now let's talk about let's say if you have reached a stage where you can no longer work with a monolithic architecture and you want to now start plugging out certain modules and services and eventually convert to a true microservice architecture, how to go about it. So this is a high-level purview of how this whole microservice architecture will look like. So all these 10 modules are divided into 10 different repos and 10 different services. And every repo has its own database. Now, depending on the use case of each of these repo, for example, catalog, you can choose, let's say, I will build catalog using the Node and MongoDB, because cataloging is very, NoSQL in nature. Generally, you need to get a lot of attributes for one single product. The attributes which are true for a mobile phone could not be true for, let's say, refrigerator. So seeing that nature, you can choose, okay, I'll use NoSQL database for catalog system, and I'll choose MySQL database for my auth system. So that's the advantage that you get with mini monolith or microservice architecture. You can choose your databases and your tech stack as per the need and the use case of that particular module. So I've shown over here multiple modules, for example, auth, cataloging, order, payments, fulfillment, communication, invoicing, custom reports. Then on the top, you have coupon and offer system, because again, coupon and offers are a very important module in any e-commerce, right? Every e-commerce company gives you offers, gives you coupons, cashbacks, discounts, and that all taken care by the coupon and offer system. So it has a lot of logic, which eventually gives you certain cashback and discounts. And then you have ticketing system, right? And again, you can connect all these databases into a replica database. Now, the way, how do you connect these databases, or how do you convert or copy all the data in these 10 databases or different databases into a replica will depend on your actual implementation. So for example, if you have everything on SQL, and let's say every database is on one RDS, if I talk about AWS, you can very well easily create a replica database just using UI. So it totally depends on how you are implementing these databases, where you are storing these databases. And in the worst case, what you would have to do is you have to write manual scripts, which will take or copy the data from their source and then eventually write again in the replica. And then based on this implementation, it will depend how far replica is from the master. So if it's in a very simple format, in the first approach that I told about, it would be in milliseconds, right? The data will be copied in milliseconds from master to slave. But let's say if you have manual scripts, it could be it could be a second node like that. And then you can have analytics tool on top of your replica so that you can give this analytical tool to different teams in your company, to operations team, to business team, so that they can play around with the data. They can find insights, they can find analytics, they can create their own reports. And again, if there is a need for writing custom reports, or writing custom CSVs, exporting certain custom data, you can write code and scripts in your custom reports service. Now, again, let's talk about how to horizontally scale in a microservice fashion. So I've shown you two services just for the sake of the space over here on the slide. So in case of microservice, you have the advantage of horizontally scaling different service as per the need. So for example, I've shown over here, in case the auth service has more traffic, which is a true use case, because as soon as the app opens, the app checks, okay, the customer or the user is logged in or not, right? And that all traffic goes to auth service. So naturally, the auth service has more traffic as compared to catalog, or maybe as compared to order, right? Only the only people who actually decides to order something would actually get to the order page or to the cart page, and then only that traffic will go to the order service. But then every traffic eventually will pass through the auth service. So you can scale as per the need. You can add more instances as per the need in case of microservices. And again, as I've shown, you can choose different databases as per your need, and even databases can be then scaled as per need. For example, if auth has large data, you can buy more storage, whereas compared to catalog, you can have less storage, right? So you have a lot of flexibility in this fashion, but then eventually it needs more maintenance. So you need a bigger team as compared to the monolithic fashion. Now, I'll walk you through a high-level DB schema of the whole e-commerce platform, what all basic and important tables that should be there, or important data sets that should be there in your system. There could be a whole lot other tables, again, depending on the niche requirements of the platform. But then these are the set of high level tables that would be there in your system. So we'll start from left to right. So in the auth, the first three tables lies in the purview of the auth service, where you have user, you have role, and you have role permission. So typically, this is called as RBAC, role-based access control, because the customer has certain role, right? The role is customer, and he can do only certain stuff in your platform. The administrator of the company, right, or the main administrator, super administrator, can do a whole lot of other stuff on your platform. So that role is super important. And then again, role permission is super important. So for example, if you have two people, one is super administrator and one, let's say, a warehouse manager who manages the inventory in a warehouse, the warehouse manager might only need to see the catalog. The warehouse manager might not need to see orders or payments, etc. Right? So you can define, okay, the warehouse manager role has only access to these set of features in the system. So for that, role permission is required. And then you can have user linked to the role, and you can have all the details around user. You can store many details. For example, you can store the details of device where user is logging. You can have that data as well. You can store all the OTPs that you send, let's say, in case of phone number and OTP verification when you log in into an application. So you can store many other information. For the sake of brevity, I've shown over here that these are the set of high-level tables that are must required. And then you eventually deep dive as you grow your system, and as you need to store more information, you deep dive and you create more tables or more data sets. Then the next set of tables would be part of the catalog, where you have category. For example, electronics is one category, right? You have appliances, you have food, etc., as the category on your catalog. Then you have product. So for example, in electronics, the product would be refrigerator. And then you have SKU. So SKU is the final smallest unit. For example, milk is a category, right? Product is, let's say, cow milk. And then SKU is 500 ml pouch of cow milk, right? Or 500 ml pouch of a fruit juice. So this is SKU, eventually, which you purchase, right? And for which you pay the price. So 500 ml pouch will have a different price as compared to a 1 kg or a 1 liter pouch, right? So I've categorized or I've shown 3 layers: category, product, and SKU. You can have more layers depending on the need of the platform. For example, you can have category, subcategory. Then you can have even have brand. For example, if your platform provides multi-brand products, right? For example, Havels, and then different other brands, you can have that table as well. So it totally depends on the requirement of that e-commerce platform. So you can have many more layers as well. Then coming to right, you have a table related to order, where once customer selects which order, which product or which SKU to purchase, then order will be created. So you can have, again, a lot of columns in the order table. For example, which customer purchased it, user ID, which SKU was it, product, amount, tax, discount, total amount, all these columns you can store in your order table. And then let's say if you have a concept in your e-commerce platform where one order can have multiple SKUs, so there can be 2 ways generally the company works or e-commerce platform works. You can order one single SKU, and every SKU you purchase is an order. Or you can have multiple SKUs or multiple items in one single order. So for that, you need another mapping table, order item, which is mapped to an order ID. And then you can have all the SKU, product, quantity of that particular SKU, amount of that SKU, tax amount, discount, what was applied, and then the other fields. And every order is associated with a payment. So you can see the payment transaction table where you can have the order ID, what was the amount of the payment, what was the method used for making the payment, which gateway was used. Every gateway, when it is interacted with, it returns or it sends a transaction ID for mapping it from our side to gateway side. And then you can have all the timestamps. Then, as I said, communication is an important piece. So every SMS that is sent out, every email that is sent out, you can store all these corresponding to the user. So for email, you need subject, email body, attachments, etc. For SMS, you need message that is sent out. And then coming to invoice, you need to store an invoice and all the details that are stored in an invoice. For that, you can have different tables. And you can, again, divide in a monolithic fashion. All these tables will be part of one single repo. In a microservice fashion, these tables will be segregated in their individual modules or individual services or repos. Right? And then if, let's say, catalog is a NoSQL database, these will be collections instead of tables in a NoSQL format. Now, I'll cover the non-functional requirements. So what we can do before moving forward to non-functional, we can take questions around the functional and the modules and the overall architecture. So if any of you have any questions around.
Yes, so people who are joining us on Zoom, please drop your questions if you have any. But we do have questions from the people watching us on LinkedIn, Sumit. So let me read out the questions for you. Okay.
Sure.
So I think, there's Rahul, and he asked, how can an e-commerce platform integrate with a third-party service such as logistic and inventory management system?
Yeah. Right. A very good question. So I'll move back to over here, right? So this design or this architecture that I've shown, I have taken an assumption that you're building every module in-house. Now, this is a good advantage of having a microservice where what you can do, you can, instead of building this particular module yourself, for example, let's say inventory, right? What you can do, you can integrate with an inventory system using APIs. Now, how the flow will work? In your cataloging system, once a catalog is uploaded, you will pass that information through API to the third-party company, whichever you are integrating with. They will also store this catalog information in their database. And then you will eventually have certain interface from their side, which you can use to upload the stock count, etc. Right? How much count, how much stock in quantity you have in your warehouse. You can use their interface, their portal, to update that count. Now, when a customer will try to make an order, your order system will make again an API call with the SKU ID to this third party and will fetch the real-time availability count from this third party. And based on that count, you will eventually show whether the product is out of stock or it is in stock, right? Instead of using their interface, what you can also do, you can, if the third party allows you certain APIs, you can again use those APIs to upload the stock right from your own interface. So all typically, to conclude this, every third party API typically provides certain REST APIs, which you can use to interact with their platform, to push data and to get the data, and eventually you do not have to write the whole system yourself. Hope this answers.
Yeah. Yes, I hope that answers the question, Rahul. And there's one more question, Sumit, and that says, how can an e-commerce platform system architect ensure scalability and high availability?
Yes, so that I will be covering in the non-functional requirements going forward.
Okay, that's good. And I think one question more, which says, how can an e-commerce platform handle multiple payment methods and ensure secure transactions?
Yes, so again, that's a very good question. So I'll come back here. Right. Now, over here, when I was showing you the payment transaction table, I have this column, which is payment gateway. Now, what you can do, you can have one more table called a payment gateway table, where you can store information about, let's say you want to use 3 payment gateways, Paytm, PayU, and Razorpay. Now, obviously, when a user is purchasing something, only one payment gateway will be used. But then at the backend, you can decide, okay, Paytm is down, let's say, and Razorpay is up. So I want to route this payment request to to Razorpay. So you can have this payment gateway table. You can store all the credentials and API keys in that table. You can have priority column. That first priority is Paytm, second is Razorpay, third is PayU. And while a payment is happening, you can check at the backend that Paytm, let's say Paytm is not available, because these payment gateways providers give you the APIs to check the availability. You can check if it is not available. You can switch to priority number 2. You can use that payment gateway to transfer that payment request to Razorpay's APIs. And this eventually this integration happens through REST APIs. So you can transfer all those requests to Razorpay. And you can store that information in this payment transaction table, that, hey, this order or this payment was done through Razorpay. This was done through Paytm. And at the end, let's say at the end of the month or at the end of the day, you can reconcile how much of my transaction volume happened through Paytm, how much through Razorpay. Because when they will settle the amount, you can actually cross-check, okay, I have to get this much amount from Razorpay, this much amount from Paytm. So that's how you can, so I call it as a switch, payment gateway switch. You can switch based on this configuration right at the backend. And you don't have to write if conditions and all in your code. You can use these table configurations to prioritize the traffic from priority 1 to 2 to 3.
Yes, yeah, that was the last question by now. I think we can continue with the presentation.
Sure. So now, let's say you have written all this code. You have written a lot of code and in different languages, in different modules and everything. Now you want to, and you have hosted it, let's say on any platform, on AWS or GCP, etc. And this is working, right? Well and good, right? So now you want to ensure certain non-functional requirements of this platform. So the first one, which is the most important, I think, because is availability. Most important because if it is not available, whatever code you write, whatever platform you build, won't be of use, right? So availability is super important. And how do you ensure availability? Through combination of certain things, right? So you need redundancy. Now, these key parameters are necessary, but not always 100% required to host your platform. Even without all these, you can host your platform. People can interact with the platform, but these are required for high availability, right? But without, for example, without functional requirement, you cannot even launch your platform. Without coupon, without offer, you cannot launch a platform. Without these, you can launch a platform, people can start using it. But then these are required for high availability to ensure best of the customer experience, right? So redundancy, load balancing, DR, which is disaster recovery planning, monitoring and alerting, capacity planning, and regular maintenance upgrade. These are major 6 areas which you need to keep in mind, which you need to ensure to maintain high availability of your system. I'll walk you through with each of these points. So what is meant by redundancy, right? So redundancy is equal to backup, right? So for example, let's say I'll take an analogy. For example, you want to get some task done. You have, let's say, servants in your home. And okay, it might happen that one servant is on leave. And still you want to get that task done. You want to have a backup of that servant, right? So redundancy is the same. If you are worried, if you want to achieve very high availability, because every system goes down, right? It's everything goes down some point in time. Nothing is 100% perfect, right? So let's say if you assume that I have a lot of traffic, even a second of downtime would affect thousands of my customers. And that second of downtime could happen with the server where your code is hosted, where logical code is hosted. This downtime can happen with the database. This downtime can happen with any other component of your platform. Every component you can plan for redundancy depending on the probability of going down of that component. So redundancy is a concept. You can apply it on different components, your logical server, your database, your Redis broker, your Kafka broker, Elasticsearch, any other load balancer, etc., etc. So whichever has the highest probability, start from that, start focusing redundancy around that component, and you move down the list of prioritization. For example, for me, I typically see those logical servers as the highest probability of going down, because as the traffic rises up, that server might go down because of CPU crunch or memory crunch. So that's the first point which I see for redundancy. Second, I check for database. And then I move down for other components. So implementing redundant systems and components is one of the most important strategy. This involves designing systems with multiple components that can take over for one another in the event of failure. For example, when you're showing the catalog list, everyone must have heard of caching as a concept, right? So to show that catalog list very quickly on the mobile app, typically at the end, on the backend side, what you'll do, you'll have cached data of your SQL data. So you can use Redis, Memcache, or other tools for caching of your data. But then you have to design in a way that, let's say that cached data is not available. You can fetch data from MySQL and then eventually show it to the mobile application. So this is one example of how do you ensure redundancy in your workflow or in your application. Then you have load balancing. So as I mentioned in the architecture, you definitely need to have load balancing so that you can have at least 2 servers or 3 servers, small servers, depending on again on the traffic. But at least you can have multiple servers so that the traffic can be routed in case one server is down. Then you have DR. So DR is typically for very high availability because it again increases cost. So DR is typically a copy of all your servers and database into a different region. So if all of you guys have worked in AWS or other cloud platforms, you might have seen that you need to have your database and your servers in certain region. For example, in India, we typically host in Mumbai region, right, with AWS. So you can have all these components, a replica of these components, even the data into different region. So for example, if a region goes down, if a data center in that region goes down, you can immediately switch all your traffic from Mumbai region to some other region. So that is what DR, because disaster, right? So disaster, when some disaster happens, flood or major power cuts or earthquakes, data centers can go down. Very rare, but can happen, right? So that's what disaster recovery planning is. Then monitoring and alerting. So as I mentioned in the initial slides for observability, so this comes under observability, where you need to, once your system is live, you definitely need to check, you need to monitor how many requests my platform is getting, what is the response time of my, let's say, homepage API. when a customer loads a home page, how much response time it is. Is it 500 milliseconds, 100 milliseconds, or 2 seconds, right? And then on top of those metrics, you need to have alerts in place. So for example, as soon as the RAM of CPU, let's say, moves above 70%, you should get an alert so that you can eventually deploy one more server if your infra is not automatically managed. If it is manually managed, which is typically the way how you grow in the platform, so you can get alerts, hey, the CPU is going above 70% or 80%. You can again do some steps either to cut down the CPU consumption or add one more server. So monitoring, which keeps a track on important metrics, and alerting you maybe on SMS, maybe on Slack, etc., etc. But then eventually there should be next steps after those alerts. Then capacity planning. So capacity planning involves or is about forecasting future demand. So for example, typically what we do as software architects, we try to understand from business, from product, hey, what is it that you think would be a rough traffic or an idea of traffic on a daily basis or particular hour in the day when you're running a flash sale or something like that. And we eventually try to make a system ready for up to 3x or 4x of the traffic. So for example, if a product manager says, hey, I am expecting 100 users per hour on my platform. So eventually we'll try to have the system ready for 300 or 400 users. So even if certain spikes are there, our system should be able to handle, right? So capacity planning involves, okay, 100 users can be handled, let's say, in a 4 GB server, for example. So we can deploy 2 servers or 3 servers of 4 GB so that can handle 300 to 400 users. So that's what capacity planning is, right? And if this is planned well, which is not obviously all the time the case, things happen, right? Downtimes happen at the initial, it's how you learn and grow. But then capacity planning is one way. Then you have regular maintenance and upgrades. Now, this point is, I've seen people miss a lot because during their day-to-day time, they keep on coding, keep on development, new features, etc., etc. Sorry, they forget that they have to maintain and upgrade certain parts of their application, whether it's libraries or operating system or framework or language. They have to maintain because the previous versions could have vulnerabilities, security vulnerabilities, could have certain inefficiencies, which eventually you would like to upgrade to, right? And this is very important. So typically, for example, what we do, we upgrade every 3 months, or we do this exercise every 3 months. And then we have certain measures in place on GitHub, which tells us, hey, we have an important security upgrade or an important upgrade. You should upgrade this library. And we eventually upgrade it and deploy it again on production. Then second non-functional requirement, which I will deep dive now into, is observability. So I've highlighted certain keywords in bold over here to focus. So it's a technology platform. Observability of a technology platform is ability to monitor and understand the internal state of the application, right? What is internal state versus external state? So external state is, okay, I have my application running on a 2-core CPU and a 4 GB RAM. But then internally, what every API is doing, or what every API's performance is, that's also very important, because overall your system might be up, but customer might be facing an issue where your homepage is loading slow, or when you're making a payment, it's slow, right? So that is what is meant by the internal state of our system. So including its performance, behavior, and overall operational health. So it involves collecting and analyzing data from various sources. For example, you need to collect information from your server. You need to collect information from mobile application, from your web application, from your load balancer, etc., etc., and eventually correlate everything to finalize, okay, this is okay or this is not, right? So it is different from traditional monitoring, where as I said, it typically focuses on measuring specific metrics such as uptime, response time, but it goes beyond monitoring to provide a holistic view. So for example, if your application is running on an infra or on a server, it correlates the RAM percentage or the RAM usage with your application response time so that you can get a holistic view. And again, it correlates with the database. It correlates with your other sources, let's say Elasticsearch with the Redis, to give you the holistic view of the whole thing, not just in silos. Okay, Redis is working fine, or Kafka is working fine, or Elasticsearch is working fine, but then it correlates everything at one point in time. Okay, for example, at 10 o'clock, 5 minutes, we had 300 RPM of traffic. At that point, we had 30% usage of CPU on the server, and we had Redis downtime, and eventually this incident happened or this problem happened. So this is what observability is. And you have a lot of tools available as a developer or someone who manages the infra to choose or to install or to integrate with your application to ensure observability. For example, I personally like New Relic. I've used it a lot. It gives very good graphs and overall metrics, which I can use to make sure that my application is up. Every of my service is up, right? So certain tools have certain restrictions or certain, let's say, if I'm running an EC2 server on, let's say, using Amazon's Graviton processor instead of Intel processor, and I have PHP as a stack, and I have Ubuntu as an operating system, right? New Relic might not work, or some other platform might not work. So they are really different factors. So you need to evaluate all these things before finalizing a tool. And then cost is obviously a big factor in evaluating or finalizing a tool. So I've shown this a graph of New Relic, how it looks. So this is what is called APM, Application Performance Monitoring. So let's say you have user service or auth service, catalog service, order service. These three services are there. Every service has this kind of graph. You can see in your order service, what is a typical response time your service has. For example, 103 milliseconds on an average. And on an average, it has 1.85 thousand K RPM on your service. So this is how you can monitor your one service, right? And if it's a monolithic fashion, the whole platform will have one single graph or it is called one single application. So New Relic provides a lot of services. APM is one, which is application performance monitoring. And this is how it gives you a trace, which is called a trace of one single API. So for example, you can see you have a bifurcation of that one single API, that, hey, this API called this function, it connected with this EC2 in the Amazon, this connected with this coupon service or this promo service, it failed, or this is the total time spent. For example, this API spent 744 milliseconds to deliver, right from left to right. This is a time series graph from left to right. And eventually you can see, okay, which component of my service, or if it was a third party, and this is very important for third party integrations, because third party integrations do not have control on the quality. So you can use these kind of traces to see, okay, I am using a third-party integration. That service is giving me longer response times. And because of that, my customer or my platform is suffering. So this traces is very important, especially if you are working with third parties, right? Now, certain benefits, faster problem resolution. You're able to dig dive at any point in time. Even if it happened a week back, you can dig dive and you can resolve those problems. You have better optimization because it gives you insights that what to optimize, right? Everyone talks about optimization, but it is very important to know what to optimize, right? And then improve collaboration. You can, as I said, especially in case of third parties, you can have good collaboration. Okay, hey, you can notify the development team of the third party that, hey, this API of yours is having larger response times, right? And you can eventually show those metrics, screenshots, and everything to eventually prove that, hey, this is the problem. Then comes in security. Now, security, everyone knows that is a must. Every platform should have. And there are some key strategies. So it is not always technical. So security is not just always technical. It's a mix of technical aspects and operational aspects to ensure that your platform is secured. For example, if you have everything technically in place, but you give key to your data center to someone not trusted, eventually your data will be lost, right? So it's a mix of operational and technical aspects to ensure security of your platform. So access control, as I said, in the first is where you need role-based control so that certain role does not have access to certain data. So that access control is, you can have two-factor authentication. Today, every portal, whether it's Google or every other website, comes with two-factor authentications. You should have that in your platform, especially in the admin portals, right? Then encryption is one most effective way. You should store your data in the database in an encrypted format, and you should opt for TLS, HTTPS. When your client application connects to the connects to the server, it should be on HTTPS. The certificate should be bought from verified sources, for example, Amazon, etc. And you should work with the latest TLS protocols. You should not work with older TLS protocols where you have vulnerabilities. Then you should do regular security. Now, this is where operational thing comes in. The first two were technical aspects. The third one is operational aspect, where you need to have regular security audits and would prefer third-party audits. For example, there are companies, cybersecurity companies, who would check your system because they are expert in that. They will check your system through vulnerability scans, penetration scans, and will give you reports that, okay, this is not, you need to fix this. So these audits, so typically what we do is we do it every 6 months from a third-party company, and they let us know that, okay, this is the problem. Then you have patch management, which is regular maintenance and upgrades. This is again operational and technical aspects both, because if you do not even consider this in your regular development cycles, you won't do a patch management. Eventually, you will lose out on a security, right? Then you have incident response planning. This is purely operational. You have monitoring in place, you have alerts in place, but if no one is watching those alerts, eventually you will have problems, right? So that what incident happened, you need to have certain response or certain SOPs. Someone is looking at those alerts, looking at those incidents, and eventually creating a plan and taking right people on the table to solve those problems, right? And then training and awareness. Every person in the team, whether it's a developer or a product manager, should be aware, should be trained how to handle any kind of problems and how to avoid preventive measures. For example, you should not create any weak passwords. You should not share your passwords with anyone else. You should not save your passwords in random sheets on someone else's computer, right? These are certain awareness that are required. Now comes in the last part of your non-functional requirement, which is latency. Every platform or customer love the platform if it is fast, right? Today, we watch shorts, which are just few seconds. So if your homepage, your application is slow, no one will use your application. That's a true fact, right? So latency is that concept. So there are multiple, again, key strategies. It's not just one strategy. You need to optimize your code. You need to use best possible techniques, best possible data structures, best possible queries to make sure every API on your application works within a second, within 500 milliseconds, within 700 milliseconds. You can use CDNs for static files, whatever images you have in your application. And catalog has a lot of images. Catalog has a lot of static data. You should use CDNs. There are a lot of CDNs available. Amazon has its own CDN, CloudFront, Cloudflare, then there it is. And there are a lot of CDNs available. Then you should minimize network round trips. For example, on your homepage, if you're making 10 different API calls, for every SKU, for every component of your API, on your page, you are making different API calls, eventually the latency will be higher because you're putting more traffic on your server, and then eventually you are doing multiple round trips, right? And for those round trips will depend on the bandwidth of your connectivity. If you're on Wi-Fi, well and good, but if you're on mobile data, it might happen that you have a slow response time. Your server is good. Your server is giving response time in a faster manner, but then your application is connecting multiple times with the server on, let's say, 3G or on 4G. Eventually, your application is slow, right? And in that case, backend cannot do anything. Frontend cannot do anything. It's just the way it was designed. It should have been designed in a different manner, right? Then you can use edge computing, where if your customer is in US, you should have data or your server and a database in the US region, so that there's minimum latency because the data is coming right from the nearest server. So that's what edge computing is. Again, load balancing. because the load balancer will route the request to the best available server. And then you have, again, you have to monitor and optimize performance to make sure to know which parts of my system are has high latency, and then eventually you can cut down on the latency part. So that's all. And this is where you can find me on Medium, on Instagram, on LinkedIn, on YouTube. And that's all. Thank you, everyone.
Yeah. Well, that was a presentation. Thank you so much, Sumit. We do have 2 questions. I think we can take those questions up before we can end the session. Well, that is from live that we had from and the live audience is from LinkedIn. And Akash is asking, how does one service talk with another service in terms of microservice architecture? Which are the approaches that we can use?
Yes. So a very typical approach or very simple approach is using REST APIs. So I'll tell you what is not recommended. So it is not recommended for one service to directly do SQL queries or directly query the database of another service, because eventually you're losing out on the service or that responsibility concept. This service should talk to the another service through some API calls. And since these API calls are internal, if both of these services are within the same network in your cloud infra, it will be very, very fast. It will be the network speed will be in GBs. So these REST APIs will be very fast, and eventually this service can take care of what data to serve you and in what fashion, in what manner to serve you. So API calls are typically the best way to do it, or one of the best ways to do it. You can have gRPC calls, and you can have certain queue systems. For example, if you are, for example, let's take an example of notification or communication engine or communication system that you want to build. So as soon as the order is placed, you want the communication service to send out communication to the customer on SMS, email, and WhatsApp. Now, order service work was to create the order, and that's done. It should not wait on the communication service to send out all these alerts, right? What you can do is you can send this message in the queue of communication service, and then communication service will pick it up from the queue, and this is called asynchronous mechanism. So you have 2 methods, synchronous and asynchronous. Synchronous can be done through API calls. Asynchronous can be done through queuing systems. But do not ever, directly access the database of another service through this service. This will, lose out the concept of microservices.
Yes. So one last question, and that is from Vaibhav, and he asks, how will the data archival work for passive data?
Right. Again, a very good question, which I think I missed in the overall architecture. And because as we grow, there's a lot of data that gets populated, right? So there are multiple methods to do it. What you can do, you generally, typically what we follow, what companies follow is you can have 1 or 2 years of data actively in the database, and you can run scripts, you can run certain processes. There are multiple ETL tools available. You can fetch out the data, the older data. You can store in certain data warehouses for archival purposes. For example, if anyone wants it at a later stage, you can download that data. The process will be slow as compared to the real-time data, but then it will be stored in some other place. So you can have different data storages. You can store it on S3 in zip formats. Try to find out a low-cost solution to store that data, right? And you can store it. Zip formats, other formats in different data storages, warehouses, and then eventually give it to someone if someone needs it. But eventually you need to run some processes time to time. You can build your own, or you can use or build or integrate from the tools available in the market and on the internet. But then the approach is low cost, and it should be available on request.
Yeah, that's pretty much. And for the people who are watching us on Zoom, so we are going to take last minute questions, guys. So also people watching us live, if you're having any questions in the last minute, please drop in your questions. And for the people who are asking, is this webinar recorded? Yes, it is recorded, and we would love to see your learnings on LinkedIn and Twitter. And if you tag us, we would specially DM you the recording of the session. And please make sure that you post your learnings of the session, what's something that you liked, what's something that you had a great takeaway from the session, and we will share you the recording once you tag us, or you can tag Sumit and tag me, tag Recro, and then we'll be good to go. I think, Sumit, we are almost done with the questions. And thank you so much. We actually had amazing audience on LinkedIn too, who are very interactive. We almost had like 60 to 70 people joining us initially, and a lot of people stayed till the end. And thank you so much for joining us till the end. Well, that brings us to the end of this wonderful session, guys. And that was the last question. I would like to thank each one of you for joining us and taking your time out on weekend and catering your time to learn something. And I'm sure that we stood up to your expectations. And looking forward for your post on LinkedIn. Please do not forget to tag Recro, and for the people who share their learnings and the takeaways from the session, we will share the recording link in the DM. So please do not forget to tag Recro in your post. And also thank you so much, Sumit, for joining us. And it was such an amazing presentation. And thank you for taking out time and sharing such an insightful information.
Thank you, Afsa, and everyone for joining. It was great having you guys. Yep.
Yeah. So before we end this session, I have a few announcements to make. We have created a community for developers called Rebase on Discord, and it is specifically for working professionals of 1+ years of experience. So if you're someone who's a budding developer and who's also 1+ years of experience, so you can connect with fellow developers, you can connect with experts, and Sumit himself is also one of the mentor and contributor in the community. So you can connect with them, and you can the link to the community is in the chat of the LinkedIn live chat and also in the Zoom chat. So please go ahead and make sure that you're joining the community and you're connecting with the other experts, and you're upskilling yourself as a developer, right? And I've also dropped a feedback form in the link. So please do fill out the feedback form and let us know what's something that you want us to improve, what's something that you loved about this session. And if you have any topics that you want us to cover in the next webinar, I think Sumit was talking about the low-level system design. I think we can have him for our next webinar. Let us know if you want Sumit for any advanced topic of the high-level system design on e-commerce, or any low-level system design that you want him to cover. So let us know your suggestions and your takeaways and advices in the feedback form. So we'll be waiting for that. And if you have any more questions, you can connect with Sumit. I think Sumit has dropped his LinkedIn. You can find him on LinkedIn, and he's also active on Medium. He has his own YouTube channel and also on Twitter. So he'll be more than happy for helping you guys, and he can help you with the queries or challenges. So please do connect with him, and also follow him on his YouTube channel and his Medium blogs. So if you're exploring career opportunities, Recro is hiring passionate developers. If you're someone who's looking out for the opportunity, or if you have your friends or colleagues who's looking out for change, please do visit Recro's website, where we have a page called recro.io/careers. The link of that is in the chat. So please go and check out something that you think is really great fit for your profession and with your skill set, and we'll make sure that we'll place you in the A-grade startups of the country. So to stay updated with such events, follow us on social media, follow us on Instagram, LinkedIn, and YouTube, and we'll be more than happy to see your learnings grow and help you upskill with more such insightful webinars and bringing amazing speakers like Sumit going forward. Thank you so much, guys. That's all for this session. And thank you so much for joining us. Take care. Stay safe. Thank you so much. Thank you so much.
Yep. Bye.